Water, this magical medium that rejuvenates the mind, body, and soul. I used to think that when you put together water and technology, it was pretty limited, mostly to underwater cameras like GoPros, scuba diving technology, and underwater pressure gauges, and marine exploration tools like remote underwater robots. However, some of these technologies don't provide a full loop of human-computer interaction between user input and technological feedback. So my co-authors and I decided to do a deep dive into academic literature to review HCI works in aquatic settings and those that use water as a tool for HCI. We dove deep into the ACM Digital Library, the IEEE Library, and recreational sports database, Sport Discuss, to look for papers around play, recreation, and technology in aquatic settings. Our deep dive resulted in finding 48 papers that considered various sorts of technological systems that use and exist in water. As we surfaced, we discovered some interesting insights, namely that water can be experienced as delight, using sensorial nature of water, example, when splashing. It can be experienced as an enabler, using the properties like its buoyancy and the ability to move more easily in more planes than on land, like in floating or doing somersaults. It can be experienced as a challenge when you need efficient movement to move through it and have regular air intake. And it can also be experienced as synergy when you use the properties of an aquatic environment to guide you in an activity, such as swimming along a black lane or flip turns. So, when we consider that water can be a problem and an opportunity for both users and technology, we were able to come up with 4 different user experiences as a framework to guide analysis and guide designs in the future. In our framework, we plotted water as a problem or opportunity for the user on the x-axis, and we plotted water as a problem or opportunity for the technology on the y-axis. In the upper right-hand corner of the quadrant, water was seen as an opportunity for both users and technology. And here, users seem to experience water as delight. Our favorite system in this quadrant were Hydraulophone, led by Steve Mann in 2006, and PumpSpark, led by Paul Deitz in 2014. Hydraulophone is a water jet-based musical instrument that can be placed in parks and public spaces for individual and collaborative enjoyment. PumpSpark was a toolkit system that encouraged prototyping various interactive water applications using small water pumps. These 2 systems use the sensorial nature of water in ways that were pleasant and surprising for users, thus providing delight. In the next quadrant, which was the lower right-hand side of the framework, we found that systems use water as an opportunity, but it offered problems for technology, the combination of which provided an experience of water as enabler. Our favorite systems in this quadrant were 3D Pointer and Sharp Punch, both developed by John Quarles in 2015 and then in 2019. Both of these systems were virtual reality based in a pool setting for physical rehabilitation purposes, by taking advantage of the buoyancy and range of movement afforded by the water. In the third quadrant, which is located on the lower left-hand side of the framework, water can be experienced as a problem for both users and technology. Because of that, we named this experience Water as Challenge. The 2 systems that we particularly liked were Clairvoyance, led by Francisco Kiss in 2019, and Rolling Sonification, led by Nina Schaffert in 2015. Clairvoyance provided visual feedback on swimming direction through LED lights in a pair of goggles to avoid open water swimmers interrupting their swimming technique to cite where they were going. Rowing sonification also provided feedback to users of the rowing system but use auditory non-verbal feedback to provide information to users about their rowing technique. In both systems, technique and efficiency of movement through the water were important in navigating water as challenge. In the final quadrant, on the upper left-hand side of the framework, the aquatic environment is a challenge for users, but an opportunity for technology, the combination of which creates an experience of water as synergy. Two systems in this quadrant we particularly liked were Rapid Scout, led by David Rasson in 1996, and Gobi, led by Annika Muhlrad in 2017. In Rapid Scout, the system takes advantage of the topography of the river to provide timely feedback to whitewater kayakers. In Gobi, using computer vision to track the black lines in a swimming pool, visually impaired swimmers are provided with feedback on their position in a lane to keep them swimming straight and avoid bumping into the end of the lane. In both systems, using the patterns within an aquatic environment allows for better navigation through water, giving an experience of water as synergy. This paper provides insight into the user experiences of aquatic systems, which can be used to guide designers and researchers in future work. Here, we seek to learn from a selection of systems within the subfield called Water HCI, where interactivity meets water. While the scope of this review is limited to recreational systems, we acknowledge that Water HCI extends beyond recreational applications. We, therefore, see this work as a stream that feeds into the broader body of work that is Water HCI. Within the recreational space, we see opportunities to develop more interesting and immersive technological experiences using water. For example, playing virtual reality games in flotation pods, combining systems like robotics, tracking technologies, and extended realities, and doing so in aquatic scenarios where interactivity has yet to be explored. However, to advance the field, future research will need to branch out, build upon, and integrate non-recreational domains. This will allow for greater articulation around the scope and opportunities within Water HCI. So, to begin your immersion into Water HCI, read our paper and dive right in.